Okay, now we have this exercise that we start with the computation of pi, which is this code here that is implemented in serial, and we want to do this thing with threads. So first thing that I have to do is I have to save this in a different space. So I save this. Now we are not in lecture 5, we are in lecture 8. In lecture 8, and there we want to main threads. So, okay, then we are in this place, cd. Wait, we are in the completely wrong place. CD lecture 8. Okay, I'll probably have these things. So when we want to compile it, we use C++ minus p threads, p thread, not threads, p thread. G++, sorry, G++, yes. So the file is, what I call it, main threads, and the output, okay, I will overwrite this as threads. Okay, now this does not yet include threads, but just see whether it runs in the first place, now completely without threads. So it takes 4 seconds, okay, and it gets the right result. So it's computing pi. Now, okay, let's just modify this. So in order for this to work, we have to include the threads. Yeah, it will always, it's not threads, it's always thread. Okie dokie. Now, there are several possibilities. Right, so, okay, let's just go back to this place here. So the file is actually prepared to run with not with OpenMP, with MPI. This is why we have here this myrank. And what I'm now doing, because I'm lazy and we don't have too much time left, I will just do a loop over myrank. Yeah? I will put here for loop. So this is defined externally. I'll do myrank equal, we start from 0, and we'll go my rank is smaller than number of processes, in this case, number of processes. It's not number of threads, because it was the way defined. So yeah, please take care, it's smaller than and not smaller equal. And we'll count up my rank. So I'm a very bad. Okay, let's not use my rank. Let's define a new one, rank, because that's probably better. Rank plus plus. So now this is going to be my loop, in which we'll do this integral here. So we need these two things well, these two lines where we get the upper and lower bound, we need these locally, and they are now not running on my rank, but on rank, right? Okay, I'm not completely sure, but I will, doesn't matter. So now here we will have to generate our threads, and the threads have to be placed somewhere. Now, in several of the solutions that I have seen, you used vectors. I'll make my life a little bit, I'll be a little bit more down to earth, and will just put there a usual array. So I put standard threads, so I call these guys threads. So this is the name I provide, and I put here number of processes. So the way I'm doing it, of course, means that this number of processes has to be known at compile time. Cannot be given as a command line argument. Yeah, number of processes. Okay, so this is the declaration of the array. And also we need to capture our result. Yeah, so this is something that some of you had to learn the hard way. Yeah, so where do we put our results actually? Let's put result. Now we have already something that's called result. I put it results because this is the individual result. Yeah, so this is an array of number of processes. Okay, same size. So then in here we have to produce our threads, and this thread has to be called with the function that we want to process. Say we have threads. So they come, of course, with the so we have a loop over rank. So we do this with rank, and now we have to. So up here we have only declared an array of threads. We have not yet generated these threads, right? So what we do here is now we generate these threads as std thread, and now we have to call a function. The function that we have here cannot be used because we need a function that gives us void. But let's think how would we do this? We'll have these arguments here. Let me just give a comma here. This will be local. Okay, I guess I just copied this here. So we'll want to give the same arguments here plus something to return. And the thing we want to return our data to is, of course, the results at the position rank. Yeah, but we have to provide a reference to this, and this we do by standard ref zip standard ref. So is this correct? I believe it is correct. So, and here we have to provide a semicolon at the end. So we have not yet provided this function. And this function does not exist yet. I'll call this integral. Okay, I could modify the integral function, but what I'm doing instead of modifying the integral function is I'll give it a new name. What name did I give it in my notes? Oh, I don't know. Okay, integral thread. Okay, so this doesn't exist. This thing doesn't exist. So because we are not using a header in this, we need to go at the head of the file and do a declaration. Any questions? So this is now not a double, but it's a void. Void. And in addition to all of this, it also uses a double reference to a double result. Okay? Now we have to implement this function. So let's go down here where we have this function for the integral. We'll copy this and paste it. So here we'll have void. And what is missing here is double reference to result. So, and now what I'm going to do is, instead of writing this function again, which you should not do, yeah, so you'll never repeat what you have already done, instead of this, we're using this as a so-called wrapper. Yeah? So, no, it's not integral, it's integral threads. I believe I called it threads. So we use this as a wrapper. This means what we are doing is we use this function to call the other function. So result is equal to integral. And now all the arguments, well, let me just copy them. We only need these. And of course, we have to get rid of the type. Integral. Now we implemented our wrapper. Okay, so this should now be done. Okay, so this here is something that we do not need anymore. Okay, now apparently threads. So, okay, we call our function, now they are generated. After they are generated, they have to be joined, but they need to be joined in a separate loop, because otherwise if we join them right now, yeah, so the next one would not be generated before the other one has terminated. So this means we use the same thing here. So now there has been the question whether we want to test for whether this is joinable or not. Yeah, so it's not essential for this here, but we should probably do it anyway. So say if threads rank is joinable. So if this is the case, we'll join them. Rank join. Okay, now we have joined them. So now this means after this everything is done, but everything is in this array. Now we could have used this to somehow think about working with mutexes or atomic operations, but we have not done this here. So what we'll very simply do Next is doing all of this again and say that our, well, yeah, that our result, actually we could just use this here. Our result is, do we need brackets? Actually, we don't need brackets here, but let's do it anyway. That the result is the sum of results rank. Okay? Everybody still agreeing? Okay, and then my rank is equal to 0, so this should be the case still. Okay. Should this work, or have we anything? Is there anything forgotten? So save. Let us see whether it works. By the way, the number of processes is set to 1 here. So okay, we'll get an error. I'm missing in 40, in line 40 probably. Ah, yeah, so it's red. Okay, I did not, you see, it's longer than my, right, so it's longer than my screen. Okay, let's see again. Did I save it? I think I saved it. Was not declared in the scope. Integral thread. Integral. Ah, so yeah, right. Integral threads. Okay, so let me see. Okay, now let's run it again with one thread. So 4.5 seconds. Okay, let's see, where do we the number of processes? Okay, let's do a number of processes equal to 10. Save again. Compile again. And run again. Okay, so we have been much faster. Actually, it was faster than yours, right?
For me, it was 9 seconds. No, 4 seconds. Or 10 seconds.
Okay, I don't know. I'm a Okay, Okay, I stop the recording of this.
I have a question.
Yeah, for the recording or without recording?
Yeah, I was just, I couldn't understand where does the function, we call the function integral.
Yeah.
I didn't understand when does it end, because I printed our result. I printed the result of each thread right after we called the function, and it was 0. And if I printed it after the thread, after we joined the threads, now it had the result.
Yes.
How does
So you have to wait until the thread has terminated.
And that's after join, right?
After join,
Okay.
yes. Right.
Thank you.
So let me